So, good afternoon, everybody. Thank you for joining today's webinar. My name is Greg Watts, and I'm Marketing Director at Terabee. We are recording today's session, just so that you know. We intend to make it available to you afterwards. I'm joined today by Clément Pellepro, if I've pronounced that anywhere near.
Yeah, that's perfect, Greg.
Good. Thank you very much.
Hello, everyone.
Clément is the product manager for our people counting technology, and he's going to give the bulk of today's presentation. If we just flick on to the next slide, we can have a look at the agenda. So really just a few words about Terabee, and then really over to Clément to talk about why use a people counting system, what are the advantages of time of flight for people counting, and then a bit about the products that we provide. I should say we have a Q&A tab, so if you have any questions, please do put them there, and we'll answer those at the end. Next slide. So we're a sensor and sensing solutions company. We specialize in four main areas: LED rangefinders, time of flight, optical time of flight, 3D cameras, thermal cameras, and radio frequency positioning systems. Next slide. This manifests itself as a range of products. You can see these on our website. They're also available from our resellers over on the left-hand side. Time of flight sensor modules, but also solutions for level monitoring, smart buildings, Industry 4.0, mobile robotics, and more latterly, COVID mitigation. That's all from me. Clément, take it away.
Yes, thank you, Greg. So now let's jump into the topic of the webinar today, which is the people counting using the 3 time of flight technology, where Terabee has now a long expertise. So let's try to first answer the question of why should you use a people counting system. Basically, if we look at the building and we start asking question about how do the people behave inside my building? How is the footfall behavior inside my building? What is the experience of my user inside it? You need to start by observing how the footfall behaves inside your building. And for that, you necessarily need some sensors, some devices, connected or not, to make sure that it gives you a first raw data that then you can start extracting to create statistics, to create metrics in order to know how many people do I have in this area, what are the traffic, the peak traffic, what is the occupancy, how is the occupancy, how it fluctuates along a day, along the weeks, along the months, the year. And then you start by observing all those metrics, all those statistics. You can afterwards take some decision about do I provide a real good experience inside my building first, and what should I do to modify this experience, to modify my workplace, my shop, the aisles of my shop. And so all that data, all this is provided by a people counting system, and that will help you growing specifically in a good manner your experience inside your building. So if we take all that in a global picture, you want to transform the movement of the people inside your building into a valuable and actionable data. And that for the occupancy monitoring, the smart building management, retail and marketing insights, obviously, and that's a big topic. And more recently, unfortunately, due to the COVID, some social distancing management, in order specifically to know what are the gauge, what is the threshold about how many people do I have, how should I control this traffic and footfall, and a people counting system allows all that by understanding the premises, the workplace, and room usage. Do my room, meeting room, where I should receive only 3 people, is actually used by 10 people, so I need to take actions here, or at the contrary side is a 10 people meeting room is used by 1 person on an everyday basis, so I need to modify this space. Obviously, behind all that is as well you need to it helps you optimizing your real estate expenditure and reduce your energy consumption and expenditure, in the sense that my building heats up all the day, but during COVID period, no one is here. Everybody is on remote, and that on the COVID period, it's very speakable. But you might want to know on an historical basis how it behaves, and then fluctuate and take action correctly. As well, another key aspect is optimizing your building design and self-level, where when my traffic arrives and I custody these specific test statistics along the time, I can put more people on the welcome desk, for example, or at the cashier, and make sure that my user, my end client, have a great experience and have the service level I want to provide them. And that's a key benefit as well of people counting. All that will create a better occupant and user experience inside your building, inside your office, inside your shop, and that will help you drive in the right manner, in the right direction, your growth. So that's a bit how and why you should know you should be using a people counting system in the end, in order to answer, to get to know what's going on inside your building, and try to find all the answers to those questions. Now, if we look at what are the advantages of using time-of-flight technology, because we are able to provide the answer to the why, but why now? What are the advantages of using a specific technology, which is the time-of-flight technology, which is the core expertise of Terabee? So before jumping into the details, let's just explain in few words how the technology of time-of-flight is working. So basically, here we have demonstrate an example with the Evo 60M, one of our product. It's a single pixel. Basically, the time-of-flight technology is an active technology, in a sense that we have a light that is emitted from LEDs in the infrared spectrum. In the case of the Evo 60M, we have 4 LEDs that emit a light, so it enlights the scene, it enlights the surface, and this light is bounced back to the sensor that retrieve this signal, and based on the time between the emission and the reception, we are able to compute, to extract a specific distance between the sensor and the surface and the object. All that is made thanks to the time-of-flight technology. And if we take a step above that, which in that case is for only 1 pixel, so we have 1 dimension. If we go with another example, which is the Terabee 3D Cam 80 by 60, so this is a 3D depth sensor. The difference with this kind of sensor is we have a wider field of view and a wider emission, obviously, which means that we can enlight a larger scene and we can start seeing more object, more information. But we don't have only the field of view; it's as well more resolution. And on the 3D Cam 80 by 60, we have 80 by 60 pixels. So as you can see, from 1 pixel to multiple pixel, now we are able to see a 3D scene. We are able to, a bit like a camera, but in the infrared spectrum, using an infrared light, we are able to see much more information. And so how does information is being seen by our sensors is the same principle than for the Evo 60M. We emit a signal still in the infrared spectrum that enlightens all the scene, and then all the different signal bounced back by an object like a table or a person or anything, a car, will bounce back with different timestamp. And those differences will allow us on the pixel grid to exactly know for which pixel, what distance we have, and then we can know directly, we can have a direct 3D information out of the signal, out of the bounced signal. Now let's take this in the application of people counting. And if we place a sensor onto a ceiling, and we have a person that passes below it, So it will start by enlightening the scene. So what's interesting to observe here is we have a certain field of view. So what we call the field of view, to be clear, is what sees the device. And here it's the yellow triangle in a sense. And from what you see is the strange thing is we have the signal that is cut by the arms, the shoulder, and the head of the person here, which in a sense will allow us then to observe clearly what kind of object we are observing. And so on the next step, which is the bounced back signal, we will have time differences between all the different height level, and that will allow us to clearly identify and see the arms of a person, the shoulder, and the head of a person, and any kind of other objects or like an animal, like a box, a chair. That's exactly it works exactly for the same principle. And all that allows us afterwards, after getting this information, to then know having a 3D shape and then starting to put some algorithm on top of that. So this is a bit what we have in the end, and the picture that you see on the right side is exactly what we get from the depth sensor, in the sense that here we have a color scale. Red is a very close distance from the sensor to the object, and the blue, in that case, is very far from the sensor, and all the colors in between gives a level of distance. And so with this information, we know exactly in red that's somehow a head, in orange that's somehow the shoulders, and then in yellow and green it's arms. And then on top of that, so that's, let's say that's the raw information that we get, and then on top of that, what we will start to do is developing specific algorithm to exactly distinguish between head, shoulder, arms, shape of objects, and so on. So to summarize, time-of-flight technology allows us, using a multi-pixel sensor, to really distinguish and to really detect people, the shape of a person in a sense, and then starting to detect it, track it, and then count it properly if we go on the step beyond the sensor, which is creating a people counting a product. So to end with the advantages of using the time-of-flight technology, that's let's say an optimized process using this technology, because we get directly the dev data out of the sensor, which lean the computation process, which lean all the computational aspects, and we don't have to add more subtlety on the computation. That's all is processed inside the sensor, and we get the 3D information out of the sensor. And then with this 3D information, we start then counting people. As it's active, it's an active time of flight, so it enlights the scene. It does not require any ambient light, and that's that's an important point to note, because we get sometimes the question is, should I leave the light on in my room? And with our sensors, you don't have to do that. Actually, it enlights its own scene, and it's in the infrared spectrum, so it doesn't require any additional light. The other aspect of using this technology is you don't need a huge computation power, because all the most complex part, which is extracting the 3D information, is done by the sensor itself. So it leans again the computation process. And you have as well a good advantage between a color and pattern independence. It means that the sensor don't rely on a specific on the external environment, in the sense that if people start wearing different colors, or the ground has different shape or colors, the light that creates the sensor by its own will allow to really distinguish the objects that are passing below it, and there is no specific color to wear or to distinguish between the ground, people, objects. The last point of the time-of-flight technology is with the low resolution, you can already create very qualitative data, and like we have with the 3D cam 80 by 60, we already have enough information to be able to count properly people and efficiently people. Rather than other system, you could think of having a wider field of view or a better resolution, a higher resolution. And already with the time of flight, we can already have consistent data with this low resolution, and we have a wide variety of algorithms to apply on this data. One of the key aspect of the time of flight technology, and this is a more and more spreading around the topic and around different industries, is the GDPR, so the General Data Protection Regulation, which has two major points. The first one is making sure that you're not able to identify any personal data. And the second one is you don't record those personal data. And so with our product, with our technology, we make sure by design, using the time of flight technology, that we are not able to identify any personal data. It's fully anonymous. As you've seen on the picture before, we are not able to identify the ethnicity of people, the gender as well. And that gives a clear advantage of being fully compliant with the GDPR policy. What it needs to be clear as well is all the data, even the raw data, is processed on the edge, and we only store the counting loads, which in a sense is as well something that is a bit sensitive for the GDPR. And so what goes out, what's inside our people counting product, it's only counting loads. There is no even raw data, depth data inside it. Where we start seeing this more and more, in which kind of industries and businesses, obviously the smart building, public buildings, offices, where the people don't want to be monitored as if we would have a video surveillance system. Even though you still have this in place in buildings, that's something specific. It's for security. It answers a specific need. People can't answer other needs, and we need to be sure that the personal data is protected, and it's not possible to identify a person or other information. And so in smart building, it takes its whole place. As well in retail, it starts being more and more common to hear from a shop manager that the GDPR policy is coming a bit in their let's say in their business. Even though we still see some other aspect where the marketing metrics could be interesting, like gender or ethnicity, but still this is a constraint that is slowly going inside this segment. And so using the time of flight technology allow you to already be fully compliant with this policy. So if we look at now very quickly to our product, we make sure that with the Terabee People Counting L, which is our people counting product using time of flight technology, we make sure that our customer can take those decisions based on the data provided by the sensor, provided by the device. All that making sure that we have an anonymous data. If you look at the picture on the bottom right, this is exactly what you can see on the device when you configure it. It's well, you don't recognize here. You see that people are passing. You probably will see actually that there is a little animal passing, but we are not able here to distinguish is it someone that you know or not. Fully anonymous. It's not a camera. So inside the device, what you will have is the depth sensor as well as a computing power, computing processes capability, which gives directly the counting data out of it. 98% counting accuracy, which means that on a total count of 100 counts, you get 2% error. So it protects the user anonymity. It's only dev data. There is no camera. I insist on that. Out of the device, you get the entries and exits. So it's a full aggregation of those two values. There is no data recorded. Everything is computed on the edge. And since we have a lean process behind that and everything is computed on the edge, the data is accessible on a real-time basis. It directly computes and the counts goes out straight away. Last but not least, we give the possibility to our user to directly push the data, so the counting data, to their own platform, their own server. If we look now to the high-level specs of the product, it can be installed from 2.4 up to 3.2 meters high and cover door widths of 1.5 to 2.4 meters wide. So on those on this last point, I'm just teasing a bit, but if you stay tuned next week, you will be able to give you a bit more width by having a bit more devices together. But I'm not saying too much now. If we look at the data, that's so that you have an aggregation of plus and minus one, so entries and exits, and those data are directly pushed to our platform by default, to our Terabee Cloud platform, where you can either connect your own platform to our APIs or use our platform and use all the benefit of our platform, which means creation of building, creation of the rooms, attribution of the devices, and so on. And then you can as well directly push the data to your own platform, to your own server. We have two protocols for that. We use HTTP or MQTT. Everything is customizable. The payload can be formalized as you wish, and you can as well set up the headers, configure the MQTT topic as you wish, and so integrate the data to almost any kind of platform that you want to use. A most recent feature is now you'll be able to download locally the counting logs from the device itself. So I think that's it. Now we're all set to answer your question. If we got any, Greg.
Yeah. Just a reminder, there is a chat facility there. So if you do have any more questions, please do drop them in. We've got a few minutes here, so we can answer a good number of questions. There are a few here. Let me pick up the first one. This is from Jose, and he asks about calibration. So does the camera require calibration, and how often?
So basically, that's a good one because we get this question sometimes. The depth sensor is already calibrated in our facilities, and what we integrate then is depth sensor plus the rest of the product. And in a sense, we don't need to recalibrate everything. The only part is at the installation. You indicate the installation height, and then the algorithm just take care of the rest once at the boot up, and that's it. You don't need to recalibrate and go through a specific process for that. So basically, the system is good to go as is.
Okay, good. Thank you. Let me see here. Leslie Ann has a question. How does the counting work if you have multiple points of entry and exit points, multiple entry and multiple exit points?
Good point. So what you need to consider is the entries and the passageways and entrances and exits. So if you have multiple entrances, you need to install our product to every passageway or door, entries, exits, and so all devices will count below what's passing below, people passing below the devices. And all the different counts then are shared either to our platform or to your platform, and the whole aggregation of the counts are made then on a database, and the differences for a specific room are then computed by addition or subtraction between all the devices. But every door for a specific space, a specific building, needs to be covered in order to properly count.
Okay,
I hope,
good.
Leslie, I answered your question.
Yep, I'm sure Leslie will drop another comment in there if that hasn't answered the question fully. And of course, we can always pick up with you after the webinar and have a one-to-one discussion as well. We're very happy to do that. Matthias has asked about wireless protocols. Is there anything planned, such as LoRa?
So LoRa is a good point, and actually we didn't validate still this technology yet. I'd be pleased to talk about more about this, but probably we need a longer session. But LoRa has some constraint where we don't have much reactivity with the system, and in case we need to push updates or trigger some information from the devices, LoRa can be a hassle for people counting. It always depends on the use cases. Some will not require a reactive real-time data, but most of the cases, and this is what we see right now with our let's say almost all our clients, they need to have this reactivity in the data, and if they could be below the second, they will trigger the message below the second. So LoRa is not so far a wireless protocol that we foresee for people counting.
All right, thank you. One question I know that is probably interesting for people to hear an answer to is about setup, and when you actually go to your location to set the device up and to configure it, how do you go about doing that?
Yeah. So inside the device, what we have is we have a local web GUI running on it, and as soon as you've installed the device, you plug it to the network through PoE. Actually, I didn't mention that point, but it uses PoE as to provide both power and then transmit the data. You can start then connect to the device. And how do you do that? You need to be connected to the same network, either with your laptop through Wi-Fi or directly wired. And you enter the web address you open your Mozilla web browser, and you enter the local web address of the device, or the IP if you know it, which brings you to a login page. You connect, and then you have a whole web GUI where you have all the parameters to set up to be sure that you have the right installation height, you have the right exclusion height, you can draw the counting area, and so on and so on.
All right, good. There was actually a follow-up question from Matthias, which I think actually leads to a bigger question. So he asks, let me just go back to the question. He asks, basically, do you need our platform? So I think the question really leads on to, how does a customer access the data, and what might a typical architecture might be?
Okay. So in the slides, I've shown that there are three possible ways of accessing the data. First is the counting data is pushed directly to our platform, and then you can either take our platform on a subscription basis or use our APIs. But you can as well send the data directly to your platform. So I don't know if you use Amazon Web Service, Azure, or any kind of cloud platform, or even a web server. You can configure the device to directly push the data to this instance, to this platform. And then there is a third part where you have the local, the downloadable data, where basically you could think of leaving the device counting, not so it won't push anywhere in the data, and then you just go on 2 days later and you click on the downloadable button, and it gives you all the logs that have occurred during the last days.
All right, very good, thank you. There are a couple of other questions actually, but I'm conscious of the fact we've kind of run over time, and actually we need to draw things to a close. But those of you that reached out on the chat, Leslie Ann, Michael, amongst others, Matthias, We do have your email addresses from the registration processes. We'll get back in touch with you for a one-to-one follow-up. So if anybody else has any questions, clearly reach out to us. We will send out an email after the webinar. Our contact details will be on there. Obviously, we're very happy to have a deeper discussion with all of you. So with that, I think we'll bring today's session to a close. Thanks everybody for participating, and please do join us for future webinars. We'll also send you a reminder of those when we follow up after today's event. So thanks very much. Have a good afternoon, everybody.
Thank you, everyone. Thank you, Greg.